Welcome to this webinar about QFTest and testing PDF documents with QFTest. I assume you already have knowledge about testing normal applications with QFTest, and you know how to use QFTest. So I don't have to tell you anything about how QFTest works. So let's dive deep into PDF testing and what's special about testing PDF documents. On the left you see a sample PDF document with some texts and images and a chart here. A PDF document contains streams. So the document itself is a data stream which references other streams. On the first hierarchy level, it just references each page. And each page references other streams containing text objects or real embedded images like here below, or vector graphics like here. And each of this component is a stream. And the text object, like the one here above, the blue one, the test report label here, contains of more streams referencing each character. A character is called a glyph at a PDF document. And these characters are rendered depending on the defined font. So the stream tells, for example, here the T, the stream tells to render a T here at the given place with a given font, a given size, a given color, and it asks the document to tell the geometrical information how to render this glyph. So the font has to be either embedded in the document or it has to be installed at the operating system. So what does this mean? A PDF document is rendered or may be rendered differently on one operating than on another operating system. For example, if you create a PDF document with Adobe Acrobat Pro on a Windows machine, it may be rendered differently on a Linux PDF viewer. For example, if there is a font used which is not embedded because you don't have a license for it, or the font is not the default font on a Linux system, the viewer on a Linux system may fall back to a default font like Arial or so on, or it may not render the text at all. So you have to test PDF documents. And it's also recommended to test these documents on Linux and on Windows and macOS, for example. Okay, so QFTest analyzes the object streams of each document when the page is opened. You can see the recognized components via View Show Components here, and then QFTest highlights all recognized components. For example, each text component is rendered highlighted in red, or embedded images like PNG or JPEGs are highlighted in blue, and vector graphics here are highlighted in green. You can see here these red ones we haven't seen before. There is no text. I will come back to this one later. Okay. Of course, you can verify these components via the means you already know from QFTest. For example, you can record checks here. Simply right-click it, and then you find the default checks. For example, here, text, text positioned, font, font size, image, the visibility, and its geometry. Okay, a default text check verifies the text here. For example, here it's test report. So what's the difference of default and the text positioned? In this case, it's the same. I will come back to this later because it's a huge difference on some documents, depending on how the PDF has been created. The text font is Calibri bold here, and the font size is 24. No magic here. Of course, you can also check the image, like you already know from testing normal applications, and you can verify its geometry, the position, the width, and the height. For images, there are even more checks available. For example, this screenshot of QFTest provides an image scaled, an image unscaled, the image itself, the visibility, and the geometry. Now, what are the differences? The default checks is just an image check, as you already know. It verifies the rendering of this image like the viewer sees it and like a human person would see it at the monitor. But because of QFTest analyzes the data streams, it can also verify and check the actual embedded image. Like you can see here, the image scaled check. It just takes a stream of this embedded image without anything above. So you can make things visible which are actually not visible when viewing the PDF document with a default viewer like Adobe Reader or so on. The image unscaled image check is a real embedded image. In this case, it's much larger than the scaled one. And this one is the data stream, in this case, of a JPEG image. The same applies for the smaller one. This graphics here you might already know from our homepage. Of course, this is just this little thing here. You can highlight it here again. The default check, as you already have seen with this one, is like the real viewer and the real human sees it, but you can also fetch the data stream from this image. In this case, the black pixels are transparent pixels, so that this combination is possible here. And of course, it's also fetch the unscaled embedded image. In this case, it's a PNG, and this is the data stream of the real embedded PNG image. Geometry checks, nothing special here to say. Vector graphics like this one above here, this pie chart here, can also be verified, and each object stream has its own check. For example, the outer one here is the whole object. This one is the green part. It's always a rectangle. So each check is a rectangle. That's the yellow one, and here you can fetch the blue one from the most outer pixel, so that it always gives a surrounding rectangle. For example, here the green one, of course, everything else is also part of this check because it's always a rectangle, and it's always the image like a human person would see it from the viewer. That's just the yellow one. If I zoom in, you see it starts here. It's a 1 pixel more, but that's fine. And geometry check, again, nothing special here. For the whole page, there are even more checks possible. You can check the text of the whole page, the text as items, the text positioned, and the text positioned as items. Positioning here, it's the same with the text. I will tell you later about this, and it's worth to know each object here, let's get to this one, no, this one, each object here is one of the text streams. For example, the test report here, the first stream, you can see a confidential value, you can see here, maybe it's this one, let's see it later. Test cases, this label here, and so on. Now let's talk a little bit about the positioning. The text positioned and the text positioned whole page check. Like I said a few minutes ago, each text object is a stream which references streams for each of the characters. So a blank or line break is not necessarily part of the stream because the actual stream of one character tells the rendering engine where to put the character. So for example, if there would be a blank here between T and E, it's not necessary that this is part of the stream because T is placed here and E is placed a few pixels more to the right. So if there's a blank or not, it doesn't matter. So what does default check do? The default check captures the stream directly. It does not add any magical blanks or line breaks or tabs or so on. The text positioned check here or here tries to add any blanks, line breaks, tabs, and so on, depending on the geometry of each of the character and depending on the location of each of the character. So it's a mathematical algorithm which tries to reconstruct these invisible characters or line breaks and so on. I will show you an example where this is really necessary later on. So you've already seen this text object here and here. If I hide the component borders, you don't see anything at all. So, for example, if you open this document with an Adobe Reader or so on, you won't see anything here. If you do an export to an text document or so on, you may see it, but directly on the PDF, you don't see it. QFTest fetches all streams, so it can also fetch invisible streams. In this case, it's a simple sample because it's just a white text on a white background, so no magic here. A normal user doesn't see it, but of course in the stream it's visible and it's trackable, and you can also fetch this information. It's also possible to place components outside of a page. For example, down below here or on the right. A normal viewer doesn't show them because they are outside of the viewport of the page, but they can be part of a valid stream, and thus QFTest can also fetch information of the document which is actually part of the page but not visible. I've seen a few documents in the past where the creator of the PDF document adds some confidential information or some debug information just a few pixels below the actual page. It's never visible to any viewer, but it's visible if you analyze the data streams of the page. Okay, now let's come to some more advanced features. I assume everybody of you know that QFTest provides a very complex scripting engine where you can interact with all components of the tested application. For example, with a Swing application, you can directly get the instance of each component and directly call the API of each component. For PDF documents, we've created a special pseudo engine and pseudo components so that all of the scripting capabilities of QFTest also apply here. For example, you can get the component instance of the test report text component. You can print it and then you can call its API. Let's execute it. Okay, here is the instance and the combined text, so no magic here. Of course, you can create very, very complex scripts. I will show you one at the very end of the webinar today. And of course, you can do anything you also can do with any other application which is under test in QFTest. You might have missed the verification point of the color here. It's text, text position, font size, and so on. However, it's not possible to directly check the color. There's a little trick. Just capture a check image. Here it is. Zoom a little bit in. Find the main color. This should be this one here. Select one pixel, crop it, and there you go. It verifies the main color of this text object. So what happens if the text changes and you may not hit a blue pixel anymore? In this case, QFTest provides many algorithms. It also provides the possibility to find a certain pixel on an image or find a certain sub-image on an image. But I will not go into details here because we provide a webinar here in the beginning of May, I think, where we explain all the magic with image checks and how to create image comparisons and how to create your custom algorithms too. Okay, let's get back to here we were. Many of you might have implemented some resolvers for QFTest. A resolver allows to define how QFTest finds components and how information of components is stored. This is necessary, for example, for most of all web applications because there are so many custom components and custom toolkits. With PDFs, it's actually the opposite. There are just 3 different components. It's either a text or an embedded image or vector graphics. So for QFTest, it's hard to tell and to recognize components whenever the document changes. For example, if the layout completely changes, it is very difficult to find the correct component again, and you may get false positives matches or even a component not found exception. So what to do? For example, here you can see these labels 100, 30, and 5, which should be linked to success, warnings, and errors. However, if I just record here a check at the 100 label, a text check, into a new test suite here to get a clean and new component tree, there's no useful information. Okay, it's a Calibri with size 15. Each of this label applies here. class index and geometry may change whenever there's a new component above, below, whatever. And then the QFTest is not able to find this component again. So what to do? You have to implement resolvers. And the resolver is always a custom implementation because it's always depending on the PDF document or even the current page. For example, here, it would be nice if all these textual labels here are linked to their counterparts on the left. That's possible with a so-called label resolver. It's a little bit glue code here, and the magic here is about 10-15 lines where we tell QFTest to look for labels on the left, but on the same vertical position, and to link them via the QFS label. If I execute this script here, I have registered as a resolver, and if I now record this check again in a new test suite to get a new clean component tree, I can see here a QFS label with the value success and a must match state. So whenever QFTest now tries to replay any check to this component, this one here, there has to be a QFS label on the left side which matches this value here. So when you can add components here above, below, but whenever you want to replay this check, it still can find this component because it's linked to this value here, success. Of course, if this value here changes on the document, you also have to adapt your component recognition here because it's a must match state here. And QFTest provides many resolvers. You can influence everything here. It's a name resolver to influence names, or a feature resolver for features, or extra feature resolver for extra features, and so on. It's a very technical part of QFTest, and you also have to have development background to write these scripts, but it's actually very important for PDF documents component recognition. So if you have ever written any resolver for a web application, you know what to do for PDF documents. Okay, this is officially documented in the manual. You can find it, your help manual, and in the advanced topic, there you can find the documentation for all resolvers. However, there's one resolver more which is not documented, the so-called element info resolver. You may have heard from it. You may have gotten one element info resolver from our support team for a different topic, but most likely you have never heard of it. So what does it do, and why didn't you ever hear of it? It can influence anything of the component recognition. Of course, you can screw up the component recognition completely. With a bad element info resolver, the component recognition may break completely. In this case, you just have to restart everything and everything is back to default. Because of this capabilities, we haven't documented it officially because the documentation would be very, very huge. However, a small sample here. From this 21 lines, actually, there's only one line of the actual resolver. Everything around is glue code. So what does it do? Let's get back to, for example, these test cases here. I record the text check again into a plain new test suite. You can see here again this class count information. A class count information here is actually not good. Why? Because each component or each text component has the same parent, the actual page. There is no component hierarchy in PDF documents. So whenever there's a new text component here, one more, one less, whatever, this class count does not match anymore. And you will get a component not found exception, or at least, or it may fail to recognize the component. If geometry is still okay and everything else is still okay, the component could be found, but if the geometry also mismatches, the component will not be found anymore. And if you don't have any other resolver like a label resolver or so on, you will get a component not found exception. So the simplest way is to simply remove the class count information for each recording. Let me start this one here, record it once again into a new test suite. Now the class count has been removed and the component recognition is better. I recommend this resolver, especially this one here, these 22 lines, to register in almost any cases for PDF documents. There are some documents where it's not necessary, but I would say in 95%, this resolver is a huge improvement for component recognition if you don't rely on any other custom resolver like this one here. Okay, so far so good. You have seen component recognition is a crucial part in PDF documents, and most likely you will have to implement your custom resolvers to get a stable component recognition. And you will also need development background to write these resolvers. So it's recommended that at least one developer can help the test team here. So one thing I would like to mention is the QFS.QFT, our standard library. Most likely you already know it. There are some standard procedures here which we provide. For example, open first page or navigate to the next page, get the page count or page number on page name, and maybe you can find something useful here. Not only for PDFs, but for all other engines or util procedures too. Okay, let's come to another document here. This sample document is part of our demo documents and demo test suite, which can be found here, help and explore sample test suites. And I want to show here again about something of text components here. Here you can see some multi-line text components. For example, this one here above, the address here, is one object stream containing of about 30 or so character streams. And here we can see the difference between text and text positioned. The default text check doesn't know anything about the line breaks. Blanks are parts of the data stream, but line breaks are not part. Like I've said a few minutes before, it wouldn't even be necessary that line breaks are part of the data stream because each glyph, each character has a defined location where it has to be rendered, so there is no need that these invisible characters are even part of the stream. So we implemented an algorithm to calculate and to heuristically find blanks, line breaks, tabs, and so on. So our text positioned here tries to reconstruct the original and the actual visible text object here. And as you can see, it added the line breaks here again. Even more interesting, it's here. Here we can see missing line breaks and also missing white spaces here. This object does not contain all invisible characters. However, here it does contain, so it's even a little bit strange what the PDF creation engine did here. However, the text positioned here reconstructs anything, so it's like a real user can see it from the viewer. Okay. Something special here, you can see something like a table here. At least it looks like a table. However, the PDF document specification does not provide this concept. There is no table at all. Actually, these are just characters placed on a defined location and some lines in between. So it's not possible to address these cells like you may know it from your Swing or web application tables. You could implement a resolver, a table resolver, based on geometry information. This is possible, but it's very difficult and it's a few hundred lines of code. So actually, nobody does it as far as I know. I have never seen anybody implementing a table resolver and item resolver for a PDF document. In most cases, the text position check with a regular expression and so on is enough here. I just wanted to add this information. So let's come to our last and our most complex sample here. I will simply press play and Let's have a look what happens. You might have seen this PDF document. It's our manual. With about, I think, more than 1,000 pages, 1,200, I think. And we do a lot of checks here. This test suite, this test case runs each night and with each regression test, and we iterate over each page and we do some checks on each page. And as you can see, it's very fast, already on page 300. Let's stop it here because it disturbs a little bit. And let's have a look what we do. So we use a procedure of our standard library to find out the page count, and then we iterate over each page. So here's some advanced scripting now. We fetch all text components, all graphics components, all shader components, in this case vector graphics, and then we verify that each of the location of the component is actually visible. Because the rendering engine here of this PDF document is LaTeX, and it may happen that a text component or an image component is larger than the actual size and the actual width of the DIN A4 page here, and it might be outside the visible viewport. And with this script here, we verify that each component is completely visible. So it's about 80 lines of code here, and this code is executed for each page. After the test has finished, we know that our manual does not contain any invisible or cropped text or images. We also check that there are no empty pages, and we also verify that there are no references. A reference, for example, is this one here. If there is a question mark, it's a missing reference, and we also verify that there are no missing references, of course. And that's a way how to verify large PDF documents and do some basic checking here. We also had implemented a spell check where we iterated over each text component, for example. So spelling errors here are verified with on each page. Okay, so that's from my side. Do you have any questions? You can tell me directly or write to the chat here.
Hello, Michael.
Yeah.
In our site, we use the PDF check to check documents that are generated for various languages.
Mm-hmm.
You know, we don't speak the languages, but fortunately, QFTest is able to burrow underneath and just, you know, compare character by character and, you know, see if they're correct. The problem that we're having is that when these documents are generated, they're generated with some variable with text. Mainly there are dates. So say like in the Arabic documents, there are dates embedded, and as you know, dates have different widths depending on the day. So we get into line wrapping problems. And so part of the text gets, you know, put onto the next line. And so we're wondering, how can we better get our test to either, you know, ignore the line wrapping or whatever?
If you completely want to ignore line wrapping of one text component, you may create a regular expression, but I think that's a little bit tricky. You could fetch the text and remove all line breaks before you verify it against the text without line breaks. For example, with a script, let's show what I mean. Let's open this one here again. For example, here.
So say like in this example, you've got a date here. Now you've got it all in. Well, go down further.
Mm-hmm.
Below the table, you got a date there, and it's all in the same sentence, but pretend that date is in text. And so what would happen is that occasionally the once word would be on the second line next to we, and sometimes it would not, and maybe the we would be on the previous line.
Mm-hmm. Okay, so where is it gone? Yeah. I would record a check here and then transform the node into a fetch text. Some variable name here. And then I can use this one here. Oh, where is it? Here. Okay, this is the text here, hopefully. Yes. And then I can do string comparison and string modifications here. For example, I could replace all white spaces, if there are any, with just nothing or a blank. Okay, I should not do any typos here. So there is the bad example because there is no line break. So if the next document would contain any line break here, for example, before this one here, so that the date is part of the next line, this little code would have replaced this line break with nothing. So it would go to one line. And what I can do now is on rt.check, I meant and check equal with the current text. Against what I really expected here. Of course, without line breaks here.
Okay, now this is good. Now the thing is, I think this works for Latin scripts. We have like that Arabic script that we would have. So that, I don't know how we would put that in the double quotes here.
Okay, with Arabic and I suppose from right to left and not left to right.
That is correct.
Yeah, it should also be possible, but most likely it's not a string, but a Unicode character in this case. And
right.
Yeah, okay, what would I say? Okay, here you have the possibility to do anything with these text objects, either string or Unicode or whatsoever. What you could also do directly with usual scripting and programming. For example, if you switch to Groovy here, you can use Groovy Unicodes and Groovy strings and modify them. It has nothing to do with a PDF anymore. After fetching this text here, it's just text and it's a normal string or normal Unicode here.
Great.
You could send a sample PDF to our support team, and I think we can find a solution here. So I can also have a view of what actually happens here.
Okay. I mean, aside from the line wrapping, I mean, like I said, we don't speak these languages, but QFTest doesn't care. It's been wonderful. So it's just, you know, these little persnickety things is all.
Yeah, that's great. Any further questions? Okay, one in the chat. Missing CMaps. I remember a support case with missing CMaps. I think the only possible way to fetch text of missing CMaps is using a text recognition, on-screen text recognition technique. If you can send a sample PDF to our support team, we can have a look, of course. I mean, yes, we will most likely upload this to our YouTube channel in a few weeks. And of course, I will also send you the sample PDFs and tests with here directly to your email address. So there was a question. Kevin, you?
Yeah, this is just like a follow-up question I sent out 2 years ago. I actually sent out the PDF, and one of your team members analyzed it was missing the same maps.
I think it was.
Oh, yeah, okay, right, yeah. Yeah, it was like deeply analyzed, saying actually, I'm reading up the email. Says the PDF contains fonts from the type 0 with encoding identity-h font encoding, not character encoding. Right. And in this case, PDF has to have embedded CMap to map font indexes to characters. But if the map is missing and the characters are only displayed as vector graphics while the font indexes, so the PDF document is missing the CMap, and Adobe Acrobat Professional fails to validate the PDF document. I think that's the email. I think I got response from you guys.
Yeah, it was me. I
remember. Yeah, is this still the case? The QFTest PDF just cannot handle any documents missing the CMaps.
Yes, that's still the case, and
Okay.
Your case was the only case where this ever happens from all of our customers and share support questions about PDF documents. Yeah, if the CMap is missing, it's not possible to fetch any textual information. I still would recommend using a tool to fetch via OCR or so on.
What kind of tool is that?
You can. There are various tools available. For example, Tesseract, which tries to construct the textual information via a given image. So you could fetch the image from via QFTest and give it to a third-party library. It's also available to call directly from QFTest, and then you will get back the textual representation. Maybe it does not work 100%, but it.
Yeah, because we did use some third-party technology like XFO to generate those PDFs. Mm-hmm. They're not created with Adobe, so yeah, it's a bit of challenging, but no big drama for me. Or just it was a nice thing to have. But, yeah.
Okay. Any further questions? No. So thank you very much for your attendance. I hope you have learned something and you have seen something new. And I tried to cover everything a little bit, starting from the basics to the advanced techniques and also to the, I would say, expert techniques on iteration over our manual. And I think you can find something interesting, especially from these scripts here. And I hope you can get better tests with this knowledge now. So thank you very much.
Yeah, this was very good. Thank you, Michael.
You're welcome.
Thanks for the presentation.
Thank you, Michael.
Thank you, Michael.
And have a nice day. And maybe we see each other again when it's our new topic, our next topic in the special webinar about image checks, image check algorithms, and custom image checks at the beginning of May, I think.
Excellent.
Okay, so goodbye and have a nice day.